Let's use Taylor series method. For Taylor series method, so this is the graph for the Taylor series. This is the graph. So you see now in that finite difference, so we said the increment which delta x is what equals to h, and delta y equals to k. So you can see now that the increment here is from here to here is delta h. Each increment is delta h. That it means is h, which means that delta x, change in x, in the increment in x axis here is delta h, and the increment in y axis is k, which is delta y is k. So now let's quickly go to the example. The example now, the question says use the method of Taylor series to determine to 4 places of decimal the value of the solution to x equal to 0.1, 0.2, 0.3, 0.4, 0.5. You might not read this 0.5 because of time, but when we reach this 0.3, you can actually do the rest on your own. So now let's start. The question is now the y dx equals 2y minus x squared. So 2y minus x squared, given that at x equals 0, y equals 2. That's the meaning of this. That y of 0, it means y of x equals 2. It means your x is 0 and y equals 2. So meanwhile your h, the increment in h will not change. So h is increasing from 0 to 0.1 to 0.2 to 0.3. We see it in this x that is given. You know that the only difference there is what is 0.1, and that's our h. That will be delta x, increment in x direction. So it's 0.1. Let's move on. Now the question again, dy dx equals 2y minus x squared. So first thing you need to do, transform it to literally one to linear one like this, so as you know affect you will know everything, and you'll be able to work it accurately. So now, you know, like I said in the previous videos, I said dy dx is the same thing as y prime, or you said y dot, you just put dot on the top of this y like this, is the same thing. So now let's transform this one now. Y prime equals to 2y minus x squared. So now let's say if this subscript y now is now k, let's assume it's k, it will now be what? Y subscript k prime equals to the same thing. Everything here we take k as this subscript. So now let's now at k equals 0 now, because you know for the x-axis in our graph, that Taylor series graph, the x-axis here starts from 0. So let's assume that k is equal to 0 now. You know, at k equals to 0. At k equals to 0, it means everything here will now turn to, anywhere you see k here, it turn to 0. So it now be y naught, y subscript 0 prime equals to 2y subscript 0 minus x subscript 0 squared, in the question like that. And the condition that it gives us is this: y of x equals to 2. So see, the condition is when x equals to 0, y equals to 2. Just substitute the value of x as x equals to 0 in the equation here, and y equals to 2. And note that this y is for y naught. Inside this is for y naught, it's representing y naught, and this x is equal to 0 is also representing x naught here. So we now substitute it, we get y naught prime equals to 2 brackets, you know our y now is equal to 2, y naught 2 minus our x naught is 0, x squared. So it means 2 bracket 2 is 4, 0 squared is 0, 4 minus 0 is 0. It means our y naught prime is 4. So that the value for y naught prime is 4. Now let's now assume that if that k now increase, I say it's increment increasing by 1 now, like increase from one point to another like this, it will now be y subscript k plus 1. K plus 1. So it's now equals to what? In one of the equations that we did, it's not first order, second order, all these things. So I said make sure you start from 0 for everything so that you should avoid error. Start from 0. For this one like this, for this one, you say y subscript k over y subscript k multiplied by h raised to power 0 all over 0 factorial. All over 0 factorial. You see that your h raised to power 0 is 1 multiplied by y, it still means y. 0 factorial is 1 over 1. That's why you are seeing y subscript k here. Plus y subscript k, that will be first derivative now. You see, power 1 factorial. Second derivative 2, h is also power 2 factorial. Third one, power 3, h is also power 3 factorial, and so on like that. Now let's now proceed at k equal to 0. Now this is Taylor series. This is Taylor series. This is series we are talking about. So now at k equal to 0 for this Taylor series, now you now say this k plus 1 will now be 0 plus 1. 0 plus 1. So equals to, when you put 0 here, it will be y naught plus y, when you put 0 here, y naught prime h. Y naught prime h. So put 0 in others here also, y naught prime h square over 2 factorial. This is the only k that is changing there because it's the one equal to 0. You now see that everything is y naught. So since everything is now y naught, and we have the value for y naught prime here equals to 4. So the next thing is to do what? And you know the equation. The equation we have there is what? Y naught, y subscript 0 prime equals to 2y naught minus x naught square. That's the equation on ground before. To get the second derivative here, you differentiate this. And anytime you are differentiating y, is what? You multiply it by the y ds, which is y prime. So now let's differentiate this one now. When you differentiate this y prime, it means what? The prime increase by 1. That will be y prime, y naught prime. You multiply it by another dy ds. It means this one will now turn to dy ds multiplied by dy ds. That's why you're having the square y ds, which is the same thing as y subscript 0 prime. Prime is second derivative of this, equals to, when you differentiate this now, it's like you are differentiating 2x, which is equal to what? If you differentiate 2x, you will guess what? 2. So but anytime you are differentiating y, you do what? You multiply by dy ds. So differentiate this one now. So you differentiate this y naught, it will now give you y naught. You know, if you differentiate this, it will give you 2 multiplied by dy ds. That's why you are seeing another y naught prime here. Minus differentiate s square here, s naught square. It will give you 2x naught. It's like 2 multiplied by the coefficient, which is 1, 2x naught, 2 minus 1, 1. So substitute the value that you already got in here, which is y naught prime equal to 4. You substitute the value. Substitute it. It means your y naught prime equals to 8. So you know that is for this one now. The second derivative, you know the value is here. This value now, you've gotten it. So you see, proceed. You now, for the third derivative here, for this y naught prime, you differentiate what you got here. The answer for the second derivative here, you differentiate again. So if you differentiate again, this one will now turn to 2y prime. It will be 2y prime multiplied by another dy ds, which is y prime. That's why you're having second derivative 2 the square y the s square. And the square y the s square is y prime. That's why you have 2y naught prime prime minus differentiate 2x, you have 2. So that's how you get it. Substitute the value you got here. This another value for this. That's the third one. So you now do what? Input. You substitute the value of y naught prime, which is 4, y naught prime prime, which is 8, y naught prime prime prime, which is 14. Substitute inside this series to get your y1. So after getting the y1, you now proceed. You know now, substitute it, and you know your h. Your h is what? 0.1. Your h is 0.1. So substitute the value of h and square all those things, equate it, you get your y1. And you make sure you approximate it to 4 decimal places like this. 1, 2, 3, 4. 4 decimal places. So after that, you proceed to your y1 now. You already know the y1. You now the same equation that you are using, the same equation. Do what? Y1 prime equals to that same equation that I used from the beginning, that's given to us. So you see it now. The only thing is that your k now, you know, here your k is 0, that's why you're having y naught. K is now 1 now. K is 1. So after that, you do what? Substitute the value. You already know your y1. Substitute this y1 here. And your x1 is what? The one given to us in the question, that x equal to 0.1, 0.2, 0.3. So that's your x1 now. That's the first increment in x. 0.1. Substitute it. You get your y1 prime. So after that, proceed to this y1 prime. So the next thing to do what? The value you get here is what? The value here is y1 prime. So you now proceed to the equation that you got for this y prime, the answer here, the equation here, that you substitute value of y1 to, you know, this value. This equation, you now differentiate this equation to get your y1 prime prime. You differentiate this. When you differentiate y, you multiply it by y prime, which is the y ds. So that's why you have this one. And you already know the value for y1 prime. You substitute it again. And your x1 is not changing. x1 is 0.1. Substitute, you get your value here. After getting this, the next thing to do is what? The third derivative, which is y1 prime prime prime. You differentiate the second derivative again, which is 2y prime, and multiply by another dy ds, which is y prime. That will now be 2y prime prime. You get it. Differentiate 2s, you get 2. So after that, the next thing to do is what? Equals to, you substitute the value you got here. Substitute it, you get your y prime prime prime, y1 prime prime prime. You now rewrite yk plus 1 for the Taylor series that we wrote here. Here. Taylor series here. Just put it here. Here. You know, you already got in your y1 prime prime prime. The third derivative, just put it here. That yk plus 1, which is 1. Our k is 1. 1 plus 1, that's y2. You get it. You just substitute all these values, y1 prime, y1 prime prime, and y1 prime prime prime. Substitute it here, and our h still remains 0.1. So because it's the increment, the equal difference between all those values, all our x. Because first one is 0.1, second one is 0.2, third one is 0.3. The difference is 0.1. That's our h. So you substitute it, you get your y2. That's how you proceed. You now start. Y2 is to be what? Like your first one. You now start again the way you start from y1. You start again that your y2 equals to this. You see what? Y2 prime, you differentiate the first equation given to you like this. Y2 prime equal to this, and your h is not changing. Your x will change, 0.2. Do it again like that. Y2, substitute the value to the first equation that is given. You just put 2 at the subscript. Do it like this. Substitute the value and just got in for the value you just got for this y2. Substitute it here. Substitute it, you get your y2 prime. So after that, you differentiate that y2, the equation at the first here. Differentiate it again to get y2 prime prime. Get it. You substitute your value into it. After that, you still do it for the third derivative. After that, the next thing is what? After the third derivative, you now substitute it to yk plus 1, which is 2 plus 1. You know you are dealing with y2. That y2 plus 1, that is y3, to get your y3, and so on like that. Thanks.